Today's video, we're going to be testing some boards, and there may be some magic smoke. Stay tuned.
Warning. The video you are about to see contains graphic, electrical destruction of innocent control boards. Viewer discretion is advised.
So in this video, we pitted 8 boards against our test equipment. The test was going to see how the thermals were on the MOSFETs and the PCBs as we were cranking current through them. We started every board out at 10 amps and then creeped it up in 5 amp increments until we started getting into the higher amperage range where we started approaching the power supply limit. If you're concerned about your bed drawing too much amperage on any of these boards, you can always add an external MOSFET to take that load off of it. One thing to note to make this test fair, some of these boards like the Creality boards had built-in onboard fuses that were very high rated in terms of what they could actually handle. Most of the boards with onboard fuses had 30 amp fuses soldered to the board. So we didn't run into any limitations with the ones that had removable fuses. We actually put a bypass in that just eliminated the fuse itself. This was done so we could remove that weak link from the equation and push the boards past their limits to see where they failed. So I hope you enjoy the video. This took a lot of time. I think we have about 5 hours of video footage, if not more, and then another 3 to 4 hours of editing into this. Next up on the torture bench is the trusty old MKS Gen L. So let's bump it up to 10. We're at about 68, 67 Celsius on the MKS Gen L MOSFET. So let's bump it up to 15. Okay, we're topping out at about 184, 185C on the MKS FET. Alright, we're at 20. And I walked away pretty quick because I wasn't sure if this thing was going to go out in a blaze of glory or not. But we're just going to let this roll and see what happens. Okay, we're going to go ahead and cut that off.
And it exploded.
We have let the magic smoke out. We hit over 250C there. It looks like, yeah, it burned the traces on the board. We've burned the back of that board. So this did handle 10 amps just fine, which is what you're going to see on most of your machines. It actually went up in smoke. I was surprised.
Not mad. I'm just disappointed.
So right now we got the FYSETC Cheetah hooked up. This is the 1.1 version, and we're putting about 10 amps through it. We're going to let that stabilize. You can see the MOSFET's getting pretty warm there. See where our FET's sitting at. Right around 47 with 10 amps going through it. Go ahead, Aaron, and push up to 15. So right around 80C on that FET with 15 amps. Okay, go ahead and give it 20. Okay, we're at 138 degrees Celsius with 20 amps going through it. Go ahead and push up to 25. Looks like we're leveling out around 243 at 25 amp load. Go ahead and pump it up 2 amps. We're at about 250C on the FET at 27 amps load, and our output voltage has dropped to 10.9. Okay, push it up to 28. Not seeing much change. Go to 29. Up, up. There we go.
The bottom line is smoking is cool, and you know it.
All right, so next up here on the kill table is the Big Tree Tech E3 DIP. This is the socketed version of their Ender 3 board. All right, so I'm gonna call it around 42C for a 10 amp load. Aaron, go ahead and kick it up to 15. Go to 20. All right, we're at 95 with a 20 amp load. Go ahead and kick it up to 25. We're at 25 amps. We're reading about 155 C on the bed MOSFET. Aaron, should we let this heat up a little more, or should we just go for 29?
29.
Do it. 199, 204. Okay, we're already in the FYSETC temp territory. We're at 250 degrees Celsius. Oh yeah, get ready to turn that off soon. Oh, it failed. So the board kept shutting down, it didn't actually smoke, so what we did was ramped up the amperage on the load tester very quickly to see if we could actually get it to fail, and that's what you'll see next.
I must break you.
Next!
Alright, next up on the kill bench is the CR10 V1&V2 board. This specific one is the 1.3, but in terms of design, the 1.2, 1.11, 1.13, 1.14, 1.15, they all use the same MOSFET. Right now we're letting it heat up, and we have 10 amps going through the board right now, and we're seeing a 0.4 voltage drop. The interesting thing to note is you can see the MOSFET is underneath the heatsink. The heatsink is on the screen, that slightly hotter rectangle to the right. But you can see the traces themselves on the board are getting as warm as what we can see of the MOSFET. So I think we're going to top out around 38-ish of what we can actually see. That MOSFET is getting cooled by that heatsink, but eventually it's going to get heat soaked. So go ahead, Aaron, put it up to 15. Let's see what our thermals look like. This would be the maximum you're going to see. Average is about 10 amps load from these beds for the CR10, Ender 3, etc. But I have had some here that ohmed out that the resistance, which you factor in the calculation, is going to pull right around 13. So we're a little bit higher, but this is going to be the absolute max you're going to see. Right around 45 on the thermals that we can see visibly. Go ahead and push it up to 20. Now we got a 0.8 voltage drop at 20 amps. Temps are still looking decent, but you can see the PCB itself is straining because of the low amount of copper on these boards. The heatsink's at about 50. Go ahead and kick it up to 25. We got 90C on some of the traces. We're at about 78, 80 on the heatsink. Okay, let's push it up to 29. Pushing that up. We're at a 140 something around the MOSFET itself. Hey Aaron, that voltage is dropping. About 230C. Alright, so we have another E3 Mini. I'm trying this other board I have because the first one was shutting down due to the 5-volt regulator. We'll see if this one has the same issue. I tested it last night and it did. One thing that is concerning to me on this board is you can clearly see that the X stepper driver is running way hotter than the others. So the others are sitting at like 35 and this one's already at 52. That's just something to note. Aaron, go ahead and turn the amperage up to 10. Oh, there we go. See the 5-volt regulator heating up? The 5-volt regulator is at 47. What's our MOSFET at? Our MOSFET's right around 39 right now. Go ahead and turn it up to 15. That 5-volt regulator is heating up again, just like the other board. Okay, turn up to 20. That regulator is going to shut down. It did? Okay. So that one just fails automatically. Is it still on? Oh, the screen shut off. Okay, well, let's just keep it rolling because the other one reset. We still got power going through the MOSFET, though. That regulator is at 153. They'll probably smoke. That regulator is at 189. The one on the other board just reset. Our MOSFET's at 162.
You want to use it to 29? See what happens?
No, let's push it up to 25.
Oh, it's dropping.
The MOSFET's at 230. That regulator's at 250. Let it ride.
Oh, fire.
Just let it ride. Did we lose? Yep. There goes the regulator.
You blew it! You had it all and you blew it!
Okay, so right now we've got the CR10S board. This is the V2.1. This is going to be the same components as the V2.0 and 2.2 in terms of the MOSFET circuitry. We've let this sit at a 10 amp load, which is your average bed load for these machines, and we're evening out right around 45 from what we can see. There is a heatsink on this MOSFET. We're going to go ahead and turn up to 15 and watch the thermals. And looks like we're leveling out right around 55, 56. I'm not seeing any drastic increases, so we're going to go ahead and bump it up to 20. This one is faring a bit better than the 114 board. Now if you look, the trace going to that terminal is around 80C right now with a 20 amp load on it. And let's push to 25. So we're right around 120 with 25 amps going through it. It's still creeping up. If you notice in the bottom right hand corner, the actual fuse, which is a 30 amp fuse, is getting pretty warm. and our voltage has dropped to 10.8 volts. We're seeing a lot of voltage loss because of the traces and the fuse restricting the current flow. We're right around 160 degrees Celsius on those traces and the MOSFET. All right, let's put it up to 29, which is the upper limit of the power supply. We're still climbing. We're at 250C on the hottest spots that we can see with our camera. There we go. Starting to see the smoke coming out. Voltage has dropped to 10.4. We're dropping a lot of volts now. Look at the volts. And there we go. Gave up the ghost. 29 amps.
Next.
Alright, so we have the SKR 1.3 hooked up here. We've had a 10 amp load on it for about 15 minutes to let the temperatures even out. And we're sitting right around 42C, as you can see there. And we're going to go up to 15. And let the temperatures climb. This does have a fairly physically large MOSFET, but the size of the MOSFET doesn't always equate to the performance of it. That is something to keep in mind. I don't think we're going to be able to kill this board, to be completely honest, because it is beefier than the other boards we saw from Big Tree Tech. I have high hopes for the SKR.
Get used to disappointment.
Okay, with 15 amp load, we're looking at right around 51C. Go ahead and push it to 20. They're slowly creeping up. You can see the yellow dots start turning white, but we're not creeping up as fast anymore. So let's go ahead and kick it up to 25. Let's go to 27. Go to 29. We got almost a we got about a 1.5 volt drop, and the bed MOSFET is right around 165. Did that power terminal just move? Do you want to kick it up one more amp? See if that's enough to send it over the edge. So that's almost 1.5 volts. Go ahead and bump it up 1 amp. Like I said, I thought the SKR would be a harder one to kill.
Bring it on, woman.
Give it one more. Because now we're pushing the limit of the power supply. This is respectable that it's actually lasting this long. This has been the strongest contender so far. Do you want to kick it up another amp or let it go? As you saw there, we ended up cutting the power. What happened was the battery backup that the power supply was plugged into went into overload mode because we were drawing so much current. However, once we moved it back to an outlet to bypass the battery backup, the board just wouldn't turn back on. We would get a backlight, but it would not. So we weren't able to continue the testing, but the traces on that board were toast and it would not power back up. So that's all we wrote for the SKR, and honestly, it was a pretty decent board. I was very impressed with how well it held up. Okay, so we have the EZBoard that's been sitting here for about 10 minutes at 10 amp load, so we can get a good baseline here. If we look at our MOSFET, it's sitting at about 39C. You can see the other two spots. We have our 3.3 volt regulator that's at right around 41, and the CPU at its hottest point is right around 42, and that's to be expected. So let's go ahead and ramp it up to 15. So now we're at 15 amps. We're going to let this heat up a little bit. Now, one thing I'd like to point out about this board is if you notice, the whole board is heating up uniformly. It's because of the extra copper. It actually acts as a heat sink for the components. If you notice on the other boards, their heat was very isolated. It did not spread out, and this is good for the long-term life of the board. Okay, so we're right about 45C for the bed at 15 amps load. We're going to go ahead and push that up to 20. It's right around 58C for 20 amps going through that bed MOSFET. Let's call it 59. Let's be fair. All right, go ahead and push it to 25. At 25 amps load, we're looking at about 81 degrees Celsius on the MOSFET for the bed. Go ahead and push it up to 29. Let's see if we can make it cry.
And I just want to assure you, I am not human, and I cannot feel pain.
We're right around 98 right now. Let's see what that PCB temp is around there. So right around 65. That's what our wires are at here. Wires are right around 54C. We're like 110 here. Go ahead and push it up to 31. I want to see if we can break this board.
I'm invincible!
Go ahead, push it to 33. Try to push 35. Bump it up to 37 amps. That was a power supply cutting off.
Well,
If you notice, the voltage dropped on the output. So if you look on the table that's on the screen here, we can see every single board with the amp load and the temperature the bed MOSFET was at. And if you notice, some of them start dropping off as we get to the higher loads. The first board we lost was the MKS at the 20 amp load. Basically, when you start seeing them spike up to 250C, that's hitting the upper threshold of what they can actually do. And then as we go further and further down the list, the last one that's left is actually our EZBoard, which I was even honestly surprised by. So if you want to have a good look at that image, go ahead and pause the video now. I hope this video was informative and fun for you guys. One thing to remember is that most of your beds only pull about 10 to 15 amps, so most of these boards are going to be fine for your average user. If you are concerned about the load from your bed affecting the temperature of the components on your board, you can always run an external MOSFET, which we actually carry some in the shop. One thing to comment on though is just because the temperatures are within specifications, the hotter you run any electronic component in general, the shorter its lifespan is going to be. So the cooler your board runs, the longer it's going to last, and the more print you're going to get out of it. Another thing that prompted the making of this video was seeing people's pictures of fried screw terminals. We've been seeing a lot of fried screw terminals in the Creality printer groups, the SKR groups, and we actually got one literally today for our EZBoard. And the majority of the causes for these issues is people not putting the wires in correctly. And what I mean by that is that when you put wires into these terminals, you do not want to have the wires tin. I'll put a link below in the description that has a PDF from Phoenix Contact, who's actually the supplier of our terminals on our boards. Now, one thing to note is when you're using higher quality terminals, as you're screwing the screw in, you can actually feel it locking into place so that the screw doesn't back out. A lot of these cheap terminals on these Chinese boards do not have that same feature, meaning that over time, as the terminal expands and contracts, the screw can loosen up and still cause a gap, which will then lead to an arc, which will then lead to the terminal melting. On all these terminals, you should either use crimped ferrules or use bare wires. Me personally, I haven't had any issues with bare wires. I have had issues with soldered ends, and that's why if you've been following this channel at all, you'll notice when I'm doing a teardown of a printer, when we do a review, one of the first things I check when we start tearing into the guts is, did they tin the wires? If they tin the wires, I snip the ends off, I strip them, and I put them into the terminal. When you do this, you want to make sure all the wire is inside the terminal. When you tighten the terminal down, do not crank it down so hard that the terminal starts bending, because you can actually damage it. But you do want to make sure you get a firm connection. If you do have one of these cheaper Chinese boards, it wouldn't be a bad idea to routinely go in and check to make sure all your terminal screws are fully seated and have it loosened up over time. I hope this video was informative. I hope you guys enjoyed watching it. I had a lot of fun making it, seeing what these boards can actually withstand. I want to thank Aaron for giving me a hand with this. All the boards that you saw on this video were purchased by us. They were not sent to us for review, and we are not compensated in any sort of way. If you guys like this video and want to see more like it, or get notified about our live streams that we have quite frequently, go ahead and hit the subscribe button, and make sure you like and share this video if you enjoyed it. That's all for today. I hope you guys enjoyed it, and as always, happy printing.